Hello. Yesterday I was optimizing and showing a bit of the new approach I have for connecting pairs of levels with several parameters, the construction distance and minimum neighbor distance and path deviation that control several aspects of the connection. Today I want to make a first approach to the final algorithm, which is a kind of tree connective structure. Let me make a little diagram. Suppose we have many levels symbolized by these dots. The idea is to choose an initial level, for example this one, and connect it to some other level, for example this one. Now this level will be connected, will be part of the connectable levels, and in each step we choose at random one of the connectable levels and try to connect it to another one. For example, we choose this one and connect it to this one, and now this becomes connectable. In the next step, we could choose this one again at random and connect it here, for example, and so on. In each step, we choose a connectable level and connect it to a new unconnected level. When a level runs out of exits, it becomes not connectable. For example, imagine this level is already used all the exits. This becomes unconnectable, and we continue. We select a new random connectable level. Suppose we connect it to this one, and this becomes unconnectable, for example, and so on. The final state will be something like this, like a network of connected levels, all of which are unconnectable because they are the end ones, or they run out of connections. Of exits, for example. So let's do that. In the function connect all levels, now we are connecting levels randomly. Let's delete this code, and first we must add variables to the levels. Connections begins at 0. And we need to know the number of pedestals it has. We know that. Okay. So it suffices with this one. Let's initialize the connectable levels with the first loaded level. And level 1 will be a pick from the connectable levels. And we must modify this function to take into account the connectability of levels. So if the level connections is equal to the size of the list of pedestals, we will skip it because that level is already fully connected. We choose between the neighbors. If this is empty, we continue the while loop. We increase two levels, level 1 and level 2. And in this function, we must increase, let's see, we make the path and we increase the number of connections. No, sorry, the level 2 we leave alone because this should be renamed outward connections, because levels will have only one inward connection. Outward connections, okay. This will fail sometimes and return an empty list. And if a connectable level becomes unconnectable, we need to change here. When we connect the two levels, we need to append level 2, and before that, if I think erase removes the first occurrence of a value from an array, we erase level 1 from the connectable. And let's see, of course we never reach this, but if the connectable levels level list is empty, we break. And also we will have a number of iterations. Yeah, let's try 200 times. Okay, this should work, but let's review. Connectable begins with loaded levels, the first element. At iteration 0, we pick from connectable, we get the neighborings. If there is one, we connect it. Okay, we are appending the new one and removing the first one if it's already connected. Yeah, this should work. Okay. Interesting. Why? This is weird. This should not occur. Obviously we must return a boolean from here. Yeah, return true, and else return false. And if we could connect, we do this. Okay. Now, okay, we connected. It's a true tree, and of course we run out of iterations, it seems. Or perhaps, let's increase the iterations. This should connect more. Obviously, this is very linear. Why is that? Because I'm blocking. Perhaps this is weird. We are let's see, connections, outward connections, incrementing only if the connection was successful. And let's see, we are selecting, let's put just in case. No, you know what, let's assert that this should be less than equal. No? Yeah, because I suspect, yeah, okay, this is very weird. Let's see the values. Okay, let's print outward connections, and if this is greater, let's print it. Okay, 2. Wow. No, this is weirder. Okay, I will investigate this at a later time, but yeah, for now I think if we ignore that error, that esoteric error, we can count this as a bit of progress. So I will end the video here. Thanks for watching. Don't forget to like, subscribe, and comment if you have suggestions or questions, etc. And please consider supporting me using some of the links below. Thanks.